Okay, good morning. Let us start with the lecture today. I think around 80 participants joined. So today we are dealing with thalamus. So we'll study this under the following headings. We'll go with the introduction part, external features of the thalamus, internal structure of the thalamus. We'll see the various connections to the thalamus and the functions of it, and finally the application. So to begin, diencephalon. The diencephalon, I said before, it's the part of the brain which is situated right in the core of the cerebrum. So this diencephalon has a cavity within it. So that cavity will be called as the third ventricle. A cavity for a cerebrum. The cavity for the cerebrum was lateral ventricle. So this diencephalon is situated right here. So here in this picture, you can see this is a medial view of the cerebrum, and we have seen that how to identify the medial view. It has the corpus callosum, the cut section of the corpus callosum. The part which is extending from the corpus callosum till the fornix here is the septum pellucidum, and beneath this is the diencephalon. And this diencephalon connects the cerebrum with the brain stem. So this is a brain stem right here. So this one, it encloses a cavity, I said, within the two parts. So as they are in a pair, so within them there lies a cavity called as third ventricle. So the cavity right here is the third ventricle. This diencephalon is divided into two parts by this sulcus right here. So this sulcus, it runs from, you can see the foramen here, that's interventricular foramen of Monro, and the foramen over here, it's the opening of aqueduct of Sylvius. So the sulcus which extends right foramen of Monro to the aqueduct of Sylvius will divide this diencephalon into two parts. The part above is called as a pars dorsalis, and the part below is called as a pars ventralis. I repeat, the diencephalon is divided into a two part by this hypothalamic sulcus, which is extending from interventricular foramen of Monro to the foramen opening of aqueduct of Sylvius. It divides it into the two parts, pars dorsalis and pars ventralis. This pars dorsalis includes thalamus. You can see right here, this is a thalamus. Apart from that, it has metathalamus, epithalamus. So epithalamus is contributed by the pineal gland. Right here you can see the pineal gland. It is connected by two stalks, so which is extending above and which is extending below. So the one which is extending above includes habenular nuclei and commissure. Commissure are the fibers which the two areas. So they include the habenular commissures, and the beneath is, you can see here the commissural fibers. This is the posterior commissure. So these all includes in the pars dorsalis. I said metathalamus. So what do the metathalamus includes? The epithalamus includes this pineal gland. So what do the metathalamus include is the body which is present just beneath the thalamus along its posterior side. So here you can see the two bodies, the medial geniculate body and lateral geniculate body. And do you remember what this is concerned with? Medial geniculate body, I said before, M for music. So auditory pathway comes to this geniculate body. Likewise, this lateral geniculate body, L, lateral for light. So it is concerned with the visual reflexes. So this is medial geniculate and the lateral geniculate body, which is a part of metathalamus. I said they have the part called as epithalamus, which includes pineal gland. So here you can see the pineal gland right in the between, and this is the green color part is the thalamus. This is pineal gland, and you can see the coming from it, the habenular commissure with the habenular nuclei, and the stria running along the medial surface. It is a stria medullaris thalami. So right here is the stria medullaris thalami. So what is this beneath this? So from here the brain stem starts. So you can see the two colliculi of the midbrain. So that's the superior and inferior colliculi. and beneath the midbrain lies the pons, and the pons is enclosed by from behind by cerebellum, and the cut open section of the cerebellum is showing a fourth ventricle right here. So this is the floor of the fourth ventricle, and this beneath is the medulla oblongata. The same is represented here. Here you can see this is a thalamus side, and the cavity right between is the third ventricular cavity. This is the epithalamus, superior and inferior colliculus, the part of midbrain. Okay, so I said about the pars dorsalis. So you have completed about the pars dorsalis. Now let us go with the pars ventralis. The pars ventralis includes hypothalamus and subthalamus. The hypothalamus is right beneath this sulcus, and subthalamus, it connects the thalamus with the brainstem. So the grayish tissue which is present between the thalamus and the midbrain here, so that's the subthalamus. So these are the parts of the so we have divided diencephalon as pars dorsalis and pars ventralis, and pars dorsalis includes the thalamus, metathalamus, epithalamus, habenular nuclei and commissure, posterior commissure, and stria medullaris thalami. To remember the habenular commissure and the posterior commissure, in this picture you can see the one which is above is H, and then comes P. H chronologically, H and P. So habenular commissure above, posterior commissure below. Yes. Now let us move ahead with the thalamus. We'll concentrate more on the thalamus. The thalamus are the pair of a large ovoid mass of a gray matter which has a pointed anterior end. You can see right here, this is the anterior end of it which is pointed, and the broader posterior end. So on the posterior side you can see the broader posterior end. If you see the long axis of this thalamus, they are oriented obliquely such that this pointed anterior end, they are closer together than its broader posterior end. So in this picture you can see the broader posterior end, they are far apart, and the anterior end, they are closer together here. This two thalamus, I said this is a pair of the thalamus, they are separated by a cavity. So cavity right in the midline here is the third ventricular cavity, and the two thalamus, they are connected. You can see right here the interthalamic adhesions. So they are connected by interthalamic adhesions. Thalamus is concerned with the relay station for all the sensory pathway which are going towards the cerebral cortex. I said before, all the sensory going towards the cerebral cortex, they relay at the thalamus, except. So can anyone tell me about which pathway do not relay at the thalamus, but they directly go to the cerebral cortex? You have your comment box, in the chat box, you can write about the pathway. Fantastic. It's the olfactory pathway which do not relay at the thalamus, but they directly go towards the cerebral cortex. Yes, I am finding very good. Let us move ahead with the next part of it, the external features of the thalamus. The thalamus, it has the anterior end. So here we have the anterior end which bears a tubercle. This anterior end is called as a tubercle, and the posterior end is rounded and is larger and is called as the pulvinar. So this posterior end is called as a pulvinar. Pulvinar means pillow-like. So the one which is broader and larger like a pillow is pulvinar. Okay, now let us see the surfaces of the thalamus. To know the surface of the thalamus, we have to see it in this section. So this is the coronal section of the brain. So here you have the medial surface of the cerebrum. This is a coronal section of the brain taken. So here you can see the line which has passed through this. The coronal section of the brain which is passing through the corpus callosum, right from its body of the corpus callosum, right? You can see here, this is the corpus callosum, its body, and the coronal section is passing from the body of the corpus callosum. When the coronal section passes through the body of the someone, you have kindly mute yourself. So it's some disturbance here. Okay, so going towards the surfaces, what I said, I have taken the coronal section right here from the corpus callosum, so body of the corpus callosum, and the section passes through the thalamus. So in this section, what you can see is the corpus callosum, which is a commissural fibers, you can see, which is crossing the two hemisphere, crossing the midline and joining the two hemisphere, and can see the cavity within the cerebral hemisphere. So this cavity, you call it as lateral ventricle. Beneath the corpus callosum comes septum pellucidum. So this is the septum pellucidum, and the beneath septum pellucidum, you can see the fornix which is hanging here. So this fornix, so here you can see this is a fornix and this is septum pellucidum. And beneath this fornix comes this gray matter, that's the thalamus. So we are concerned with this thalamus, right? And in between the thalamus, you can see the third ventricular cavity and interthalamic adhesion. You can see here the two thalamus, they are joined by this adhesion. What about the rest of the area? So this area gray is the gray matter called as cortex, the outer cortex, and you can see the white fiber is projecting, and this is the internal capsule fibers. You can see this the internal capsule fibers which is separating the gray matters here inside. So once I said there are few collection of the gray matter within the white matter inside. So those collection of the cells, they are included in ganglia. So this is the caudate nucleus, the part of the basal ganglia, and this is lentiform nucleus, which includes globus pallidus and putamen, is a part of basal ganglia. So this is the internal capsule which separates the thalamus from the lentiform nucleus. I call this together as lentiform because it appears like a lens. So it's a lentiform nucleus, and the gray matter right here is subthalamus. I said the thalamus separates the midbrain, is separated from the midbrain by this gray tissue, that's the subthalamus. Okay, now let us come back to the surfaces. So thalamus has the following surfaces along its medial. So this is the medial surface of the thalamus, which forms the lateral wall of the third ventricle. So this is the third ventricle. So the medial surface forms lateral wall of the third ventricle. This is the superior surface of the thalamus. It forms floor of lateral ventricle. Is that clear? So this is the lateral ventricle. So this is forming floor of this lateral ventricle. Okay. Now on this side, you can see it's the lateral surface, and the lateral surface separates this lentiform nucleus, is separated from this lentiform nucleus by this white fiber right here. So this white fiber I said as internal fibers. I guess this is over internal fibers. This is a part of a white matter of the cerebrum which carries the fibers to and fro from the brain. Okay, and along the inferior surface here, right here, you can see along the inferior surface, it is separated by a subthalamus. So right here is the subthalamus. Okay, these are the different surfaces which are present: medial surface, superior surface, lateral surface, and the inferior surface. Okay, let us move ahead. Internal structure of the thalamus. The thalamus mainly consists of gray matter and small part of the white matter. So what white matter are included? Let us see. So those white matter will be on its periphery, will be surrounding to it, and some white matter part will be penetrated within the thalamus. So those white matter are named as external medullary lamina. So it is present right here. You can see the striations here. So this is the external medullary lamina. Let me orient you with this. This is the anterior end and this is the posterior end of the thalamus. And here you can see the interthalamic adhesions. So this is the medial surface of thalamus and lateral surface of thalamus. And the external medullary lamina is present along the lateral surface of the thalamus. And there is the stratum zonale, which is present. This is a thin layer of white matter which is present along the superior surface of the thalamus. And there are few more fibers which penetrate the thalamus and divide the nuclei within the thalamus into different parts. So this white matter is in the form of Y-shaped, which has bifurcated anterior end and the stem like this. So it is Y-shaped and it's called as internal medullary lamina. So the white matter are in total external medullary lamina, internal medullary lamina, and stratum zonae. Let us go to the main part, which is the gray matter of the thalamus. So the gray matter of the thalamus is very complex. So for the ease of understanding, it has been divided into the different area. You need to concentrate how the name has come. I will simplify, try to simplify it. I will tell you how the name has been given to, how the nomenclature has been given to this different nuclei of the thalamus. So let us begin with the gray matter. I said is divided by this Y-shaped internal medullary lamina into the anterior part, the medial part right here, and the lateral part, which is larger. So further, this anterior part includes some nuclei. So the nucleus which is present along this anterior part is called as an anterior nucleus. The nucleus which is present along the medial part here, right here, is divided as further. They have the dorsal surface and the ventral surface. So they are divided as medial dorsal and medial ventral. So the name here given. So medial ventral cannot be seen from here as it is viewed from above. So you can medial dorsal, which is seen above here. So this group of nuclei which is present on this dorsal surface on this medial part are medial dorsal, and the one which is on the ventral is a medial ventral. So the basic here is, for we have to in total divided it as anterior, medial and the lateral, and each of this like medial and the lateral, they are further divided as ventral and the dorsal. So one which is appearing on the dorsal will be medial dorsal and the other one is medial ventral. Let us go towards the lateral part. Now this is a bit complicated. Just look at here. It is divided further as ventral tire and the dorsal tire. The ventral tire includes those group of the nuclei which are present along the ventral side. So you can see here all V here. So all these are tire nucleus, and those group of nuclei which are present on the dorsal side are the dorsal tire nuclei. So it includes all this. Now we have to categorize it further as all the many sensory fibers, they relay at this particular area. So we have to categorize into different segments. They are further categorized as the dorsal tire. It has pulvinar, the larger area called as a pulvinar, and it is divided as lateral dorsal and lateral posterior. It is on the dorsal side and on the lateral side, so it's lateral dorsal. But this is the one more which is on the posterior side, so this is a lateral posterior. Okay, so the dorsal tire includes these three: lateral dorsal, lateral posterior, and the pulvinar. Along the ventral side, we have these three tired nuclei. The nuclei arranged in this three way. The one on the anterior side is called as a ventral anterior. One on the posterior side is called ventral posterior. The other one in between, you call it as ventral intermediate or ventral lateral. Okay. This ventral posterior is further divided as ventro-posterior lateral and ventro-posterior medial. The medial will be somewhere on the medial side and the lateral will be more on the lateral side. Okay, so grossly, we have divided this nuclei into this anterior, the medial part and the lateral part. The medial part has this following nuclei: medial dorsal, medial ventral, and the ventral side has these two tires, ventral tire and the dorsal tire. And the nucleus are lateral dorsal nucleus, lateral posterior nucleus, pulvinar nucleus, and along this ventral tire, the nucleus included are ventral anterior, ventral intermediate or ventral lateral, and ventral posterior, which is further divided as ventral posterior lateral and ventral posterior medial. It sounds a bit complicated, but if you go according to its nomenclature, I think it's easy for you to remember the names of it. Okay, so this do not complete the list. So to complete the list, let us go with some other nuclei which are around. The other nuclei which are present, they are present within this white matter, intermedullary lamina. So they are named as intralaminar nuclei. And one of it is larger and is present in the middle is called as a centromedian nucleus. So there are intralaminar nuclei which has centromedian nucleus. And the nucleus along its medial surface here is the midline nucleus, and the nucleus along its lateral surface is called as a reticular nucleus. So this is the midline nucleus. Here you can see it's named as midline nucleus along its medial surface. So it is in vicinity to which ventricle? You have the chat box open. You can message the midline nucleus is in vicinity to which ventricle? You can type in your chat box. The midline nucleus is in relation with which? Fantastic. Third ventricle. Yes. It is in relation with third ventricle. Correct? Okay. Now come back to the reticular nucleus. The reticular nucleus is on its lateral surface right here. So this is the nucleus over here. Two other nuclei which are included functional in the thalamus, but they are not part of the thalamus, but they are the part of metathalamus. They are medial and lateral geniculate body. This is the medial geniculate body and this is lateral. Functionally, they have been included in the thalamus. Okay. So this is about the naming of all the nuclei. Now our duty is to give a connection, afferent and efferent connections to the thalamus and to know the functions of this tract. So let us begin with the connection part. Functionally, the nuclei which I have divided anatomically right now, functionally they are grouped as specific nuclei, association nuclei and the non-specific nuclei. The specific nuclei are those which acts as a relay center for ascending pathway, and from there they give their efferent pathway towards the specific area in the cerebral cortex. So they give their output to the specific area in the cerebral cortex. So those nuclei, they are grouped under the specific nuclei. To give example, you have heard about the spinothalamic tract. So you know thalamus is relay center for all the sensory pathway. So spinothalamic tract relays at the thalamus. So and it from here, so it is one of the part of ascending pathway and it goes to the cerebral cortex. So this includes the nuclei which is involved in the relay center for spinothalamic tract will be a specific nuclei. So to give a brief idea, the specific nuclei are along the ventral tire group. Ventral tire group. So which are the group nuclei? Ventral anterior, ventrolateral, ventroposterior. All this they are in the specific nuclei. We'll see in a detail next what are the connections and pathway of this specific nuclei. One more nuclei said association nuclei. The association nuclei do not relay the ascending pathway, but they have the connections with the association areas of the cerebral cortex. So those are included in the association nuclei, and the nuclei which are included in it, this dorsal tire nuclei. So the lateral dorsal, lateral posterior and the pulvinar, they are included in association group of the nuclei. And the rest of the nuclei, they will be included in the non-specific nuclei because they neither connect the ascending pathway nor they have the connections to the specific areas of the cerebral cortex. Okay, so let us begin with the connections of the specific nuclei. Sensation. Which type of sensation you know? Exteroception and proprioceptions, right? So the exteroception and the proprioception from the entire body except from the head and the face is received by few fibers which are ascending from there. So those fibers, now concentrate here in this picture. So this is here in this picture. You can see this from here. This is the lateral spinothalamic tract, which has crossed right in the spinal cord level and has ascended. So when it ascends, this lateral spinothalamic tract, it reaches the brain stem and it gets its name, like it gets named as spinal lemniscus. Note this. So the lateral spinothalamic tract is nothing but the spinal lemniscus when it is in the level of the brain stem. Further, it comes and relay in the thalamus, and obviously it has to go to the sensory area of the cerebral cortex. So the spinal lemniscus is its path in the middle in the brain stem. Likewise, we have proprioceptive fibers. Proprioceptive fibers, they lie along the posterior column. So we have here fasciculus gracilis and the cuneatus along the column. These fibers, they carry a proprioception. What do you proprioception? It's the sensation of the muscle and the joint sensations and vibrations and 2-point discrimination. So those sensations on this posterior column, which is included in fasciculus gracilis and the cuneatus, it will ascend in the brainstem. In the medulla oblongata, there are two major nucleus. Nucleus cuneatus, right here you can see the nucleus cuneatus and nucleus gracilis. The fasciculus gracilis and cuneatus, they relay right here and cross in the brains, in the medulla oblongata. And what you name that crossing fibers as? You have your chat box open, you name that crossing fiber as, that crossed fibers in the medulla oblongata carrying the proprioception is named as, write down in a chat box, sensory decussation. Very good. Roll number 6, Janvi Patil. It's a sensory decussation. Correct. The sensory decussation fibers, they happen in the medulla oblongata. They cross to the opposite side and they ascend towards the thalamus. Now, these fibers which are ascending in the thalamus, here, right here, sorry, which is ascending here, it is grouped together and they are known as medial lemniscus. If you have studied the sections of the brain stem at the medulla oblongata, at the pons and the midbrain, you have come across this word, spinal lemniscus, medial lemniscus. The medial lemniscus are nothing but this posterior, the fibers along this posterior column. They are carrying proprioceptive. So this medial lemniscus, they come and they relay in the thalamus. Okay. So next, when I will be speaking about the spinal lemniscus, medial lemniscus. So this name I'll be using, not the lateral spinothalamic tract or the posterior fibers of posterior column. Okay. So these are the external fibers and the sensory and the proprioceptive fibers coming from the entire body except for the head and face. What about the head and face? From where should it come? It should come from some cranial nerves. The sensory fibers for the face and the head should come from cranial nerves. The cranial nerve which is involved in the sensation of head, face, neck is the trigeminal. And the trigeminal, the tri means it has three parts. One is the ophthalmic, other is maxillary, the third is mandibular. So it carries the sensations from this area. It relays in the trigeminal ganglion. So there is a nucleus, spinal tract of trigeminal nerve in the brainstem. So those nerves, they relay at this place, they cross to the opposite side and ascend in the form of one lemnisci called as trigeminal lemnisci. Now we have studied these three lemniscus: spinal lemniscus, medial lemniscus, which carry exteroceptive and the proprioceptive fibers of entire body except head and the face, and trigeminal lemniscus carry proprioceptive as well as exteroceptive fibers, the pain, touch, and the temperature. Yeah, through this trigeminal lemniscus, and they relay in particular area of the thalamus. Now let us see at which area do the medial lemniscus, trigeminal lemniscus relay. So it relays in the ventro-posteromedial. Where is this located? So if you have seen this, this is the ventral tire nuclei, this is ventro-posterior. So medial to it is a ventro-posteromedial. The medial lemniscus relays at trigeminal lemniscus relays at ventroposterior medial nucleus. From here, and spinal and the medial lemniscus, they relay in ventroposterior lateral nucleus. So it is right here, ventroposterior lateral nucleus. So extroseptive and proprioceptive fibers, they relay along ventroposterior nucleus. On the medial side is for the trigeminal lemniscus, and on the lateral side includes the spinal and the medial lemniscus. Okay, and from here, where do you expect the fibers should go? To the some area of the cortex, cerebral cortex. So that area is the area number 312. Area number 312. So in this picture, you can see these are all afferent fibers which are coming to the thalamus. This is the thalamus, and from the thalamus, which is going towards the cortex, here you can see these are all efferent fibers. So the fibers from the thalamus, they are going into area number 312, sensory area number 312. So all these three lemniscus, they relay in this nucleus and they go into the area number 312. So obviously their functions are carrying exteroceptive and proprioceptive sensations. Only point to remember is of trigeminal lemniscus. They carry both extro and the proprioceptive sensations of head, face, neck. And this is the exteroceptive and proprioceptive sensation of entire body except head, face, neck. Okay, so now we have covered these two nuclei, ventroposterior medial and ventroposterior lateral. Let us go further with anterior and the lateral nucleus, ventroanterior and ventronucleus. So this is concerned with motor activities. So what the motor is doing here? We know it's the thalamus is a relay center for all the sensory pathway. What about the motor? I said before that whenever the skillful movement is involved, you need a programming movement. So that programming is added by, or it is it's added by cerebellum and the basal ganglia. So it's the globus pallidus right here. So the cerebellum and the globus pallidus, they are concerned with the fine tuning of the movement. So when the desired movement is intended, it checks whether the movement performed is correct or not. So it sends a signal back towards the cerebrum, and before going to the cerebrum, it relays in the thalamus, and it sees whether and it goes to the premotor area for the programming of that particular actions. So that is what it is concerned with. So let us see where does this the nuclei lie. So I said first the cerebellum. The cerebellum has the dentate nucleus. So right here you can see the dentate nucleus. The fibers from the dentate nucleus, it passes to the red nucleus, which is present in the midbrain. So these fibers from here, they relay and go into the thalamus. The fibers coming from the globus pallidus, they will come into the thalamus directly. So these two, they manipulate the movement. They help in the manipulation of the movement. And the fibers coming from this cerebellum, they are called as a dentato-rubro-thalamic tract. Dentato because the dentate nucleus, rubro because of the red nucleus, and this thalamus. Dentato-rubro-thalamic tract. And the fibers coming from the globus pallidus towards this called as thalamus fasciculus. So those fibers, they come, relay and go into the premotor area number 6. So both this cerebellum and the globus pallidus, they are concerned with comparator actions. They compare the action performed correct or not, and then the signals is sent back to the cerebral cortex. So thus they are acting as relays. The function is the relay center for cerebellar impulses, striatal impulses. Okay. So here, so few specific nuclei are left. It's the medial and the lateral geniculate body. So the medial and the lateral geniculate body, they are concerned with the signals from auditory and the visual signals. The medial geniculate, M for music, medial geniculate is concerned with auditory. Likewise, lateral geniculate is concerned with L for light, concerned with visual. Yes, visual pathway. So The medial geniculate body, which is located, I said it's functionally it is related with thalamus, but it is anatomically it's separate as a metathalamus. This medial geniculate body, it gets the afferent fibers from auditory fibers from inferior colliculus. If you see the track of the auditory pathway, it comes right from the inner ear, cochlea. From the cochlea, it goes into the cochlear nucleus in the brainstem. Few of the fibers they decussate, few fibers they lie laterally. They ascend and they relay at the inferior colliculus in the midbrain. From there, they come into the medial geniculate body. From the medial geniculate body, the auditory pathway goes into the auditory area, primary auditory area number 41 and 42. So this is the pathway, auditory pathway, which is medial geniculate body is a relay center for this. So this is the function of it is relay stations for auditory impulses. Likewise, for the visual impulses, the fibers are coming from optic tract. Now, what this optic tract means, you know, there is an optic nerve which is coming from the retina. They mix together at the chiasma, optic chiasma. And I said, few fibers they decussate, few fibers they remain ipsilaterally. And in my previous lecture, I said about homonymous hemianopia. Yes, so it's because of this crossing of the fibers. The crossing of the fibers happens because of those nasal fibers they cross, and the temporal fibers they lie ipsilaterally. So these fibers carrying the ipsilateral temporal fiber and cross the nasal fiber that tract on one side after the optic chiasma is called as optic tract. So are you getting that? So this optic tract, it relays in the lateral geniculate body, and from this lateral geniculate body, the fibers are sent towards the primary visual cortex area number 17. You know where this area is located? It's located in occipital. So meanwhile, I am revising again. We have covered all the specific nuclear. I said they are specific because they are relaying along the ascending path and the specific area in the cerebral cortex. So these are the following specific nuclei. We have covered about ventroposterior medial, ventroposterior lateral nucleus, and this is the ventroposterior medial and lateral is located along this region. And then we have covered about ventro-anterior and the lateral part. The globus pallidus relays at ventro-anterior and relays at ventrolateral. At the end, we had seen about the visual, the fibers coming from visual pathway and the auditory pathway, and the medial geniculate and the lateral geniculate body is the relay center for the fibers coming from this pathway. Okay, I think all have joined. Let us move ahead with the next part. Just a second. Okay. Okay, let us move ahead with the non-specific nuclei. The anterior nucleus, it is present within bifurcation of that Y-shaped structure. So here is the anterior nucleus which is located, and this nucleus is a relay center. It's one of the constituent of Papage circuit. I think this is over in the physiology. This Papage circuit is concerned with recent memory. So when you talk about the recent memory, so let us know what the Papage circuit is. So it's the neuronal circuit which begins from, so in this picture you can see, it begins from the hippocampus. So here you can see there is a hippocampus. It begins from hippocampus and ends right over the hippocampus. So that's the Papage circuit. We have to trace it completely. So right here is the hippocampus. From here ascends the fornix. You know this, the fornix ascends right here. The fornix ends in the mammillary body, which is present near the hypothalamus. From the mammillary body, fibers are given to the thalamus along the anterior nucleus of the thalamus. And from this anterior nucleus of thalamus, the fibers they project again towards the cingulate gyrus. So here there is a cingulate gyrus which is marked with the blue. From here it comes back via the isthmus into the hippocampus back. So this tract, this neuronal circuit is the Papez circuit, and anterior nucleus of the thalamus is a component of this Papez circuit. This is concerned with the recent memory. Okay, so what you say about the afferent fibers coming to the anterior nucleus is from mammillary body. So that's the mammillothalamic tract, and the fibers from the anterior nucleus are towards this cingulate gyrus. So the fibers projecting to the cingulate gyrus is a efferent tract. Yes, so they are concerned with recent memory. Let us move ahead with the rest of the non-specific nuclei. The medial dorsal nuclei. The medial dorsal nuclei, they are, right here is the medial dorsal nuclei. The medial dorsal nuclei get the connection from the amygdaloid, afferent, and efferent connection to the prefrontal area. If you remember, the prefrontal area, it is concerned with the personality, mood, and emotional balance. So they have the intercommunications. This prefrontal area, they have the intercommunications through which it functions. So it is the relay center for this region. Okay. Next comes the dorsal tire nuclei. What I said about the dorsal tire nuclei? The dorsal tire nuclei are the specific nuclei. This nuclei, sorry, they are the association nuclei. They associate the sensory areas. There are different association areas. If you know, the sensory association area is superior parietal lobule, and the sensory association area of the visual and the auditory, you know, it's surrounding the 17th and surrounding the primary visual area. There are the sensory association areas which are located. Now we have to trace out the afferent pathway for the association areas. So lateral dorsal and lateral posterior. So this lateral dorsal and the lateral posterior, it is a relay center for the association, maximum association, which integrates the sensory informations, and from here it goes into the superior parietal lobule. But afferent to this, from where do you expect the afferent to this? They should get the afferent from the sensory signals, and the sensory signals, all the sensory signals, maximum sensory signals relay in this ventro-posterior nucleus, which has ventro-posterior lateral and right. So they should get the afferent. They should get the afferent from this nucleus, ventro-posterior, medial, and lateral, right? And efferent to this, it should go to the association areas. That's in the superior parietal lobule and cingulate gyrus. Okay. The function of this is it integrates the sensory informations. Likewise, the pulvinar nucleus is concerned with the relay center for association areas of and the auditory pathway. So the visual and the auditory, those tracts, they relay in medial geniculate and the lateral geniculate. So the afferent to this pulvinar should come from medial and lateral geniculate, and from here it goes into the association area of the cerebrum. So you know the association area of the visual cortex and the auditory cortex. The remaining nuclei are the reticular nucleus. The reticular nucleus is concerned in the relay of reticular activating system. What is this reticular activating system? There is an ascending reticular pathway, and it is concerned with wakefulness and alertness. So you are alert right now because of your reticular activating system. And the others they influence, like the visual, the light, and the sound. It influences this reticular activating system. When it dims, you sleep down. The reticular activating system is concerned with state of wakefulness and alertness. They are located in the brainstem. So they get the afferent right from the brainstem reticular formation, and they give the signals in a diffuse manner to the cerebral cortex. So they are concerned with the reticular activating system, reticular nucleus. Likewise, the intralaminar nuclei, they get the signals from this brainstem reticular formations, and they, from here, the efferent goes to the different thalamic nuclei and corpus striatum. They are concerned with awareness of painful stimuli at the thalamic level itself, at the level of thalamus itself. it do not need to go to the cerebral cortex, but at the level of thalamus itself, it understands the painful stimuli. So the intraminer nuclei is the relay center for this. Okay, so thus we have covered all the nuclei. Connection. We have seen the connections of the association, specific and the non-specific nuclei. As we are now aware of all these connections, now you can tell about the functions the thalamus is concerned with. The function of the thalamus are obviously the nucleus which it relays, the fibers which relays at the nucleus. So the major function of the thalamus is it is the relay stations for all the sensory pathway except olfactory pathway. And at the level of thalamus itself, it is able to recognize the pain, temperature, and some tactile sensation at its own level. And it also influences the voluntary motor activities, I said, by the comparator action of and the basal ganglia. And through the reticular, as it is the relay center, activating system, it is involved in state of wakefulness and alertness. The Papage circuit I spoke about, the Papage circuit, the nucleus is located along this Papage circuit. So tell me about which nucleus is involved in this, or nucleus of the thalamus is involved in this Papage circuit. The question to you is, which nucleus of the thalamus is involved in the Papage circuit? Correct. It's the anterior nucleus of the thalamus is involved in the Papage circuit. What about the which now answer about the which nucleus is involved in the state of wakefulness and alertness? Which nucleus in the thalamus is involved in the state of wakefulness and alertness? Fantastic. It's the reticular nucleus. Correct. State of wakefulness and alertness, it's the reticular nucleus. And now coming to the determination of a mood, which is concerned with the prefrontal and the cingulate gyrus. Which nucleus is involved in the relay center for this prefrontal and fibers going to the prefrontal and cingulate gyrus, concerned with the determination of the mood? If you remember, fantastic, medial dorsal nucleus. Very good. So these are the basic all the functions of the thalamus. Let us go to the one of the applied aspect of it. That's the thalamic syndrome. Thalamic syndrome occurs when the patient is recovering from the state of the vascular lesion. The feature of this is the threshold of the pain, touch and the temperature is decreased. So it gets the pain from the opposite side of the body. So when it is in the point of recovering, it gets the O reacted. So that's called a thalamic O reactions. And when the threshold is reached, the sensations are exaggerated. So even the pin prick is felt as a burning pain. Okay, so that's the thalamic syndrome. So that's all about thalamus today. So we'll stop.